Welcome to qnawire.
We're given the following chemical reaction, and the first step before we continue with the problem is that we're going to require to balance this reaction out. So in this case, we're going to multiply the coefficient here by 3, over here by 2, by 3, and by 2 over here. So in this way, what is going to happen is that our reaction is going to be completely balanced. How we got these numbers? Well, we can observe that the chlorine atoms are clearly unbalanced on both sides of the equation before we added these numbers, so we need to multiply by the other number by the common factor in order to get the correct result. So now that we have the correct chemical equation, we're going to be able to continue with the problem. So we're told that we have a mixture of 41 grams of magnesium with a molar mass of 24.31 grams per mole and 175 grams of iron chloride, which is going to have a molar mass of 162.2 grams per mole. We want to identify which one is going to be the limiting reagent and determine the mass of the excess reactant present in the vessel when the reaction is complete. So what we're going to do in order to get this is calculate the amount of mole of magnesium, calculate the amount of mole of iron chloride that we're going to have, and then calculate how much of that can react with the other compound. So the amount of mole of magnesium is going to be equal to the mass divided by the molar mass. So 41 grams divided by 24.31 grams per mole is going to give us 1.68655, let's round it out over here, mole of magnesium. And of iron chloride, we're going to have 175 grams divided by the molar mass, which is 162.2 grams per mole. This is going to be 175 divided by 162.2, 1.079 moles of iron chloride. So now that we know the amount of mole of each of the reagents, what we're going to do is calculate how much this is going to react with the other compounds. So 1.68655 mole of magnesium can react with here we're going to put the stoichiometric coefficients according to our chemical equation. So we know that 3 mole of magnesium is going to react with 2 mole of iron chloride. So this is going to be able to react with up to 1.1244 mole of iron chloride. So with this information, we already know that the limiting reagent is going to be iron chloride. So now the only thing that we need to do is calculate how much of the magnesium is going to be left. So we're going to start with the amount of mole of iron chloride, and we're going to proceed in the same way. 3 mole of magnesium reacts with 2 mole of iron chloride. Notice that now the factor is going to change a little bit. So 1.079 times 3 divided by 2 is going to give us 1.6185 mole of magnesium is going to react. So that means that the amount of mole of magnesium left is going to be equal to the initial amount minus the one that reacted. Let's put magnesium initial minus magnesium that reacted. This will be 1.68655 minus 1.6185 mole. This is going to give us 0.06805 mole of magnesium, which corresponds to a mass, according to the atomic weight of magnesium of 24.31 grams per mole. Of 1 point to a mass of magnesium left equal to 1.6543 grams. So in our answers over here, in this case we need to round up to, we're going to need to round this up to 2 grams. So the final result is going to be, the limiting reagent is going to be iron chloride, and we're going to have 2 grams of magnesium left after the reaction happened.